Hello everyone, welcome to AI Anytime channel. In today's video, we are going to build a search EO PDF app. Okay, so in the last few months, you would have seen many applications like chat with your data, chat with your PDF, etc. So today also we are going to build chat your PDF, but in this video, we are going to completely rely on open source models. We will not use any closed source models or services. For example, OpenAI, Azure OpenAI, Pinecone, DeepLake, Vectora, etc. We are going to rely on open source models and of course Langchain. So we'll start with Langchain, then we'll move to sentence transformers for embedding, and then we'll utilize ChromaDB as a vector store, and in end we'll use an open source language model called Lamini LM. Okay, so they are not that big or that large when we call large language model, but they are good enough to give you decent accuracy for whatever task you are trying to do when it comes to natural languages, right? For example, semantic search, summarization, etc. That's the purpose of this video, guys. This is the only video that you need at this moment when you want to do some kind of hobby projects, pet projects, or even a POC at your workplace. You might be a student, academia, researcher, or you are a working professional in an IT industry or in a startup. This video will help you build POC, right, end to end. I will also cover that what are the fundamental things that you need when you are trying to build some kind of a POC with large language model. So this is basically text based, but I have other videos when we have created chat with audio, chat with video, etc. You can also refer to those videos. So let's get started. So if you see, currently I am on this Hugging Face repository called Lamini LM, a diverse herd of distilled models for large scale instructions. Not that large, but that's really, it's extremely fascinating at this moment, because just putting more parameters in your language model will not take you anywhere, guys, because there will be a situation then we will not have the energy, right, that will fuel the data centers. We have to look at some other approaches, that how we focus on some kind of novel architecture or different kind of data models when we talk about high quality data. And that's what a new language model called Phi-1, that was paper was released by Microsoft. I have a video. My last video was on Phi-1. Maybe you can have a look at that. And this model, Lamini T5 738M, so 738 million parameters by T5, very underrated, extremely underrated language model is T5, one of the most underrated model. Okay, so T5, Flan T5, T5 XL, blah blah blah. There are a lot of other T5 models that you can, that has been variant of the original T5. We are going to look at this model, Lamini T5738M. I already have a video on Lamini, but that for summarization task. Maybe you can have a look at that as well. It's by MBZ UAI. It's an university in I think in United Arab Emirates. They also provide some of the PhD courses. It's a very good university coming up in this Arabian country, right? So this model has been basically released by them. It's for text to text generation model, you can see, and then we have, it's a torch based backend, transformers and a lot of other details. So this is what we are going to use. With this we'll also use Langchain, the most rated GitHub repository currently in the last, I think the last 6 to 10 months after the origin of ChatGPT. Langchain is the most used library in last 6 months, okay, because it does all the heavy lifting for us. So we are going to use Langchain for a text splitter, basically for text pre-processing. Okay, it's easier to use Langchain for text pre-processing, and then we'll use one of the chain. For example, maybe we can use retrieval QA, because it's going to be a retrieval model that we are utilizing. You can also use conversational, but maybe I'll create one more video of, to create a chatbot, interactive chatbot. This is not a chat with your doc or chat with your PDF application, guys. Many of my fellow YouTubers are creating chat with your PDF, but they are just asking one question and retrieving information. It has no context, no memory, and no follow-up question ability, right? So it's basically a search kind of a tool where you come and ask your query and it will retrieve some information. So this is basically a question answering tool. So this is what we are going to build, but first I would like to explain you what I mean by it. So let me just write it over here and show you. So the first thing, search your PDF, excuse me, search your PDF. Now this can be one PDF or multiple PDF files. How does this work, guys? What are the things that we need? So let me first write it very quickly. The first thing is that we need some PDF files. In this video, we'll only use one PDF just to save some time, because when it comes to embedding and inferencing, it might take a lot of time when you have multiple PDFs, mainly for the embeddings part, when we are creating embeddings through the ingesting that data, right? So the first is PDF file. Now once we have the PDF file, what we need is, we need minimum of 16 GB of RAM. Even on 8 GB of RAM it should work. I'm talking about CPU. We are not going to utilize GPU in this case. 16 GB of RAM, and that too on CPU. But it's better if you have a VRAM. Better if you have a VRAM. VRAM is nothing but when you have a GPU, right? So these are the things that we need at this moment, right? And of course Python. And Python 3.10, because we are going to use a library called Accelerate. And Accelerate is very beautiful because it helps you, run large models. Okay, they compute heavy models, and that's why we are going to use that library called Accelerate. Okay, that's what we are going to use. So Python 3.10, because if you are using less than 3.10 and you are installing Accelerate, you might get some errors, in that one. So these are the requirements for this. Okay, now how are we going to do step by step? So the first thing that we have, the workflow. Let me just write here workflow. How it looks like. Okay, you have your PDF files. We have your PDF files. Now the first thing that we have to do, we have to use Langchain. So Langchain will be used for text pre-processing. When I say text pre-processing, it kind of loads the file, kind of uses character text splitter or recursive character text splitter, or can be any other text splitter, right, to split that text on some chunks. That's what it does. So we're going to use Langchain here. Why are we using Langchain? Is for loading. So loader, and the next thing is text splitter. Now this text splitter has many other modules there. Okay, it depends on what you want to use. Now once we have that, the next thing that we use, sentence transformer. So let me just maintain the uniformity of colors there just for your better understanding. Then we need sentence transformer. Why I'm using sentence transformer? Let me just explain. So sentence transformer works good when you have limited infrastructure. Okay, you don't have a GPU, and even on GPU it works well, because sentence transformer is very good for question answer kind of a task where you have to retrieve information from the embeddings. That's where sentence transformer works good. Now you can also use many other basically the embeddings model. For example, you can use Vicuna embedding, so it has their own embeddings from Hugging Face pipeline. You can utilize those as well, but those will be very compute heavy and it might not run on your CPU machine. So we'll use sentence transformer. So sentence transformer have been used for basically to create the embeddings. And we are going to use mini LM or something. Okay, so let me just cut this, and we are going to use mini LM. So I'm just writing mini LM. I think it's V6 or something, V6 version, okay, of sentence transformer for embedding. So we have Langchain, and then we have sentence transformer, and the next thing is we need some kind of vector stores to store that embeddings, because that's why we are talking about Pinecone, Vectra, Deep Lake, and a lot of other closed source. Deep Lake might be you can call it like the hybrid source kind of a platform, but when we talk about Pinecone and Vectra, they are basically closed source platforms or tools which will provide you vector databases. So we need open source here, and that's why we are relying on ChromaDB. So let me just write it. So what I'm going to write here is first that it's vector stores. We need vector stores, and for vector stores what we need is ChromaDB. So I'm just writing ChromaDB. It runs natively. It's open source. Very good, very beautiful. So ChromaDB, but you can also use fast CPU, which was out. On GPU you want to use, you can use GPU, but it's also had a CPU kind of a module. You can use that. I think fast was created by Facebook AI, and you can also use that as well if you want to use. Okay, and then earlier we have used Elasticsearch and all. I hope you are aware about it. But if you don't know, you can also use their alternative like fast, for example. So we are going to use ChromaDB, and in this ChromaDB our focus will be on Parquet. It's a file format basically for embeddings. We'll store our embeddings in Parquet format. Okay, this basically store all our embeddings. Now once we have ChromaDB thing here, okay, once we have the embeddings, now on top of these embeddings we will run our LLM pipeline, LLM pipeline, and that we will use it from Hugging Face. So let me just write Hugging Face, and that's we're gonna use Lamini model, guys. So here we'll use Lamini, and Lamini has many weights, okay, different kind of weights. So I'm gonna use Lamini T5 738M. This is what we are going to use for inference. This will basically infer the embedding. So for inference we are using this as an LLM. So this is basically workflow, guys. Okay, ChromaDB again will be used here to get the embeddings, and then we'll pass that to LLM pipeline that we'll create, and then we'll use the inference. And this is again combined. So let me just do this is again combined with Langchain, because we are going to use a chain there, retriever chain, and then ChromaDB will get the embeddings for you. So this is how end to end it looks like, guys. This is a workflow. Whatever you do with your documents, you can of course you can have a couple of other layers, like if you are looking at some other ingestion techniques, you can you can use those as well. But mainly in more than 90% of cases, if you are building something with your document, the text data, the files, this is going to be workflow. Either you use an open source model or a closed source model. What will change if you use closed source? So when you use closed source, this sentence transformer thingy that you see, it will get changed in OpenAI embeddings. So this will get changes in OpenAI embeddings if you use closed source, and this will change in Pinecone if you are interested to use Pinecone, because it's very famous. So this will change in Pinecone, and here we will use either GPT 3.5 Turbo or something. Simple thing. This is what it will happen, right? When you use closed source, no much difference. The workflow remains same. Okay, you have to understand the fundamentals. Then you have let me just write it in 1, 2, 3 very quickly. What are the things you need? You need Langchain, and then Langchain, then you need embeddings. And once you have the embeddings, you need vector stores. Then again you need some chains by Langchain again, and that chain will kind of again uses your LLMs, and that will again use retriever, so again which is embeddings. This is the flow, guys. This is what you do. Okay, and you can do custom templating prompts, custom prompts by Quarks and all. This is a high level overview. I hope you understand. Okay, this is what you need. Simple thing. It's not a rocket science, right? You have documents that can be plethora of documents. You create embeddings out of it, store that in vector stores. Why vector store? This is a question in interview. People are asking this question. Why do we need a vector database? Vector store. Why not a SQL database? This is a question, and one of my friends appeared in an interview, and somebody asked him this question, and inbuilt algorithms, semantic search, cosine, Langchain, Jacquard, fundamental things, right? Why do we need a vector database? Because it has so many features. It helps you with lower dimensional space. You have store your embeddings. It has inbuilt default algorithms, cosine similarity to find out. It helps you in tasks like semantic search, question answering, chatbots, etc., etc. This is how you understand, right? Now this is on the theoretical part, the workflow part. If you are interested in code, you may move to the code part as well. But I want you to understand that this is very simple. Okay, and either you use open source, closed source, but you should be aware about the models, 7B, 13B, 40B, 30B, trainable parameters, and whatever else we need. So let me now start writing the code. Let's move to the code. Enough of theory, guys. Enough of talking now. So if you come over here, okay, Lamini T5 738, let's start writing the code and build a QA tool right there. Okay, search your PDF tool. Now if you come back, I have a folder called local LLM search, local large language model search. When I open that, you can let me open in terminal. So when I open in terminal, I'll just go inside code and it will open in VS Code. Now let me activate deep learning environment in my, I am on Anaconda currently. Conda activate deep learning. You can see I'm inside this, and so I am back on my Ubuntu system, guys, for at least this video. Okay, I love Ubuntu. I like Linux. Okay, and Conda activate deep learning, and you can see. Now let me help you understand what are we doing here. Let me show you. Ignore, git ignore, because we have to push this on GitHub. So I have a git ignore, and that git ignore is for Python. So it will look at VNB, PyCache, VNB folder, etc., APIs, blah blah blah. It kind of takes care of all those things when you push this to any Git based management or the version control that we use, right? The services. Now I have an MIT license. Anybody can use this code commercially or however you want to use it, but make sure Lamini T5 is commercial. You have to check that. First thing, these are the requirements.txt before you build this kind of application. When I say this kind, 80% of this module or libraries will be common wherever you are watching, whoever's video you are watching and whatever code you are using. 80% of this will be common. So what I have used Langchain, my favorite library at this moment. Then I have Streamlit, because we are going to create a Streamlit interface where you can ask query and it will retrieve some information, and also with the source citation. It's very important, right? That if a large language model generates some response, it will also give you the citation, that from which paragraph, which document it has retrieved the information, and that's why we'll also use this for UI. Okay, and then we have transformers. If there would have no transformer, I doubt that we would have seen ChatGPT. So credit goes to Transformer and Google for releasing that attention is all you need paper in 2015. And then we have requests. So request, and then we have torch as a backend. Then we have accelerate. Accelerate helps you run large models. Okay, and then we have bits and bytes. Then we have PDF-6. PDF-6 is for again bits and bytes, safe tensors, etc. So we are looking at safe tensors. I'm also creating a video on safe tensors, guys, because it's better to use safe tensors rather than pickle file, because that's not those secure. Pickle will not give you any security when it comes to model. So we have to look at some other alternatives, and that's where safe tensors help. So that video is also coming. Now we have PDF-6. You can use PyPDF. You can use PyPDF2. You can use any other PDF miner, Plumber, whatever. Okay, this is basically to to do the processing and manipulation with the PDF files. Then we have beautiful soup. Then we have sentence transformers for embeddings. And here comes the ChromaDB, the vector stores. These are the requirement. If you are on Anaconda, you might install it in wherever environment you are. But if you are on Python, like you don't have an Anaconda, just create a virtual environment and install all these libraries. Okay, that's how I hope you can install it. So I'm not showing that. Now, very important, what you have to do, you have to come here, Lamini T5. What I have done in my case, because I haven't installed it directly through Hugging Face pipeline and all. Okay, I just downloaded this folder because I think it's better to download this folder because that's not that big. It's 738 million parameters. You can see I have downloaded all the model weights and config file and just on. How you download it? What you have to do, you have to click on these three icons and you have clone repository. When you click on clone repository, it shows you two things. The first thing that you have to do, you have to install git LFS for large file. So LFS is required for large file because you are installing more than 500 MB file. So you need LFS. Then you have this clone HTTPS Hugging Face that repository that we have, Lamini T5. When you clone this will create this folder, Lamini T5 738M. Okay, basically, and it will have all your weights. You can see I have .bin, model. This is the main kind of weight. Then we have special tokens, tokenizer, etc. I'm doing it locally, everything. Internet is not required once you download all these libraries and also this this Lamini T5 model weights. So if you come over here, what I have done, I have created a folder called DB. I'll show you why I have created this, and then I have a folder called docs. So this is a file. Let me just show you the file also. So let me open docs, and when I double click, I open this. This is the file, fast track climate action. I have downloaded this from UN SDGs, United Nations Sustainability Development Goals. This is the file, and it has many questions, this like paragraphs to help people understand what is climate change and related things. This is the document we are going to do. You can use any other document. You can use Gita, Bible, Quran. People have built Bible GPT, Quran GPT, Gita GPT. You also build something. You have IPC, Indian Penal Code. If you are in India, it's very difficult for people to understand what IPCs are, right? So you can build something like IPC GPT. You build football GPT with football tactics. You build some other GPTs, whatever GPTs you want. UN SDGs GPT. You want to build, child abuse GPT, for child rights GPT. Whatever document that you have, whatever knowledge management or knowledge base that you have, you build that GPT. So this is the document that we are going to use now. Okay. If I come back here, you can see this is the docs, and keep that in docs folder. Now let's create couple of files, and I like to give some credit to I Martinez GitHub repository, okay, the owner of that private GPT repository. Private GPT, if you don't know, private GPT kind of uses GPT for all, Groovy and Llama's model, and that's a very compute heavy. We will do our own. But couple of code snippet I have taken from I Martinez private GPT repository, and all the credit goes to them, kudos to them, but I have made a lot of changes in that code snippet as well. So let's do that. The first thing that I'm going to do here is I'm going to create couple of files. The first is constant.py. So the constants that we are not going to change. So constant.py, the first file. The next file will be app.py, that will have all our Streamlit logic, and the next thing that we'll have is we'll have ingest.py. So let's write ingest.py as well. So I'm just going to do ingest.py. So these are the three files that we need, and in these files we'll write our code. The first thing is constants. So let's write it. So this basically is for ChromaDB settings. So I'll explain that where we'll use this ChromaDB settings. Now the first thing is import OS, operating system, and now the next is from Chroma. So let me just do. So from ChromaDB.config. We're going to use some settings from ChromaDB. I'll just want to import settings here. The first will be capital. So import settings. That's it. And here we'll start writing the code. So let's define the Chroma settings, guys. So define the Chroma settings. And I'm just going to write Chroma settings. And here it will have settings. And here we go. We'll start writing all our parameters inside this settings module. Okay. So setting, the first is ChromaDB implementation. Basically what we are doing here, we are saying, okay, we need Parquet, we need DuckDB, okay, in that format we need, and then we also need a directory. So our directory is nothing, that's called persist directory. So persist, so that's basically, you can see here the DB folder that we have, right? So that's basically our persist directory. In that we will create an index folder and couple of Parquet files, that the embeddings. Okay, that's what we're going to do here. Okay, so the ChromaDB, and in this ChromaDB the first is, sorry, it's not ChromaDB, it's ChromaDB underscore implementation. So I'll just write impl, and here I'm going to write DuckDB plus Parquet. So let's write Parquet. Here we go. So DuckDB plus Parquet, and the next is persist directory. So the persist directory is nothing but the DB folder that you see. So you can see this DB folder. That's our persist directory. And the next is anonymized telemetry. Okay, we'll keep that false. So anonymized telemetry. So telemetry. I hope I spelled it right. Anonymized telemetry is a boolean, so we're gonna do false here. That looks good. Anonymized telemetry. This is our constant.py, where we are handling some ChromaDB settings that will help us create the embeddings and store that in a Parquet format through DuckDB, and we have our persist directory as DB. That's what we are doing, anonymized telemetry. Now let's move on and let's write the ingest.py, guys. Okay, so this ingest.py is very intuitive. Here we'll use Langchain for heavy lifting, and we'll also do a couple of things. Okay, so let's do that. So the first thing is from Langchain. So from Langchain.text splitter, that's what I'm going to do here. So let's do in order. So the first is document loader. So document underscore loaders. I'm going to use import PyPDF. So the first is PyPDF loader. I hope okay, Py PDF loader. The next is directory loader. If you want to load directory, from directory you have many files, you can again use directory loader there, and directory loader, and you can also use PDF miner. That's what I'm using. So PDF miner loader, but I also imported Py PDF loader. If we want to use Py PDF as well, we can use that if we get any error. So PDF miner loader, that's the first thing. So PDF miner loader, directory loader, and Py PDF loader. The next thing goes is text splitter thingy. So the from Langchain will import in order as well, so you get a complete understanding that how it works. So from Langchain dot text splitter import recursive text splitter. It looks as the character level, recursive, character and text and splitter. That's it. So recursive character text splitter from Langchain dot text splitter. The next thing gonna use embedding. So from Langchain dot embeddings, and I'm going to do import sentence transformer, it's transformer, and then embeddings, that's what we're going to do here. Sentence transformer embeddings dot embeddings. And now here comes the vector store. So from Langchain dot vector stores import, I'm gonna use here ChromaDB. So that's basically Chroma, not the DB. So vector stores. So in order, everything is happening right now in order, even the imports. But now we'll not follow any order for this, at least for OS we can't follow any order. Import OS, and now let's use that constant that we have created. I need the chroma setting from there, so I'm gonna do import chroma settings. We are done with our imports for ingest.py file, guys. So what we have done here, we have directory loader, PDF miner loader that will load the PDF file, give it to text splitter, give it to sentence transformer to create the embeddings, and then store it in that ChromaDB that we have, vector stores. That's what we are doing. Now let's define our persist directory. So persist, not required OS path, let's directly call DB, but you can also handle it from .env. That's what they do in private GPT, guys. Okay, persist directory in DB. Now write a main function. So def main, and let's write that in def main. The first is for, we have to look at that root. So for root, a directory of files in OS, that looks nice, os.walk, and then we're going to use docs is our folder. So in this docs, you can see I have our doc. You can also create docs, any other name like source documents, docs, data, any other name, whatever name you give it, and this should contain some documents that can be Word documents, PDF, CSV, JSON. Langchain supports 14 different types of file formats. I think they would have updated as well. When I checked last, it was 14 different file formats, and that's why I love Langchain. Now we have os.walk docs, and here you can see this looks nice. Okay, so let me just do for file in files at least. I'm not gonna use tab 9 here, is that's what it's using in background for file in files. And now if file ends with, I'm not gonna use the complete thingy here. Okay, Py PDF, maybe this looks nice still here, and not this. So let's remove this. So what we are doing here is we are checking if the file ends with PDF. So if files ends with PDF, let's print that file in terminal to track that if that works. So print file. Now that is okay. Now here we'll use our loader. So the loader, and that's we're gonna use PDF miner loader. So PDF miner loader, it's a function, and inside this we're gonna pass our os.path.join. This looks nice. This is okay. Now this is done. Excuse me, sorry. I'll just do Control G, cut this off. Okay. Now loader, PDF miner loader. Now let's come out of this, if, and then, so documents, a variable documents, and in this documents I'm gonna just do loader.load, and this will load documents loader.load. And now here is the text splitter. So let's define a text splitter, recursive text splitter. This looks nice, recursive text splitter. I'm gonna pass the chunk size and chunk overlap. So that's called chunk underscore size every 500. So chunk size 500 and chunk overlap. So chunk overlap, let's keep smaller chunk overlap to save time there. Okay, so chunk overlap with this looks nice. File PDF okay, here is something wrong. Now this is okay. Now text splitter. So we have documents has loaded the file. Now we are giving that file to recursive character text splitter. You can also use character text splitter if you want. Now text splitter. Now the next thing is text, the variable text, and that's where we're going to use text splitter dot split. And in that split documents, I'm going to pass, I think it's documents, and I'm going to pass this documents. Now this makes sense. So text splitter dot split documents. Now here we'll create the embeddings. So let's write create embeddings here. So I'm going to write create embeddings here, and in now this create embeddings here, I'll create the embeddings. This looks nice, so let's use this. So I'm going to use embeddings sentence transformer and not this, at least now. We'll use this later once we are making the inference. Here we have to define the model. So the model that we are going to use is all mini LM6 or something. Okay, so I think it's all mini, or let me check that. So I'm going to do here is sentence transformers Langchain. That's what I'm going to use, sentence transformer Langchain, and here we go. This is what we need. So this is our model name. If you are using Hugging Face embeddings, you might get some error, some time. Okay, it has happened with me. It might need a token or something. There are some issues with Hugging Face embedding pipeline there. So this is the model that we're going to use. So let me just remove this model here, by the way, and this. So this is the model that we are using, all mini language model L6v2, the version 2. Okay, this is the model, and create vector store here. So it is okay, but this is not how it works, by the way. So now we have used the embeddings model. Okay, all mini LM language 6v2. Now here let's write our DB. So the DB variable, and this will have chroma. So let's write chroma and dot from underscore documents, and this is embedding. So the first thing is text, so we have to pass the text, and then we're going to pass embeddings, and then we're going to pass persist directory. So persist directory equals to persist directory, and we're going to also use client setting. So that's the setting, the duckdb parquet, right, the client setting, and my telemetry, we don't need that telemetry thing. So client and client underscore settings, let me do a alt G. So client setting, and client setting is nothing but the chroma underscore settings, and that's what the DB thing that we have done. So what we are doing here in this, guys, chroma dot from documents, that's coming from Langchain. We are passing the text that we have splitted, right, using recursive character text splitter. We are giving the embeddings that has been created by sentence transformer, and then we are giving that directory path, persist directory, where we will store our embeddings with the help of chroma settings. That's what this piece of code is doing here. Now once we have DB, we'll just persist it. So it's saved. So persist db.persist, and then we do db equals to none. That's it. That's what we're gonna do here in this case. Now if that's it, so we have written our code for ingestion, guys, ingest.py. You can use lot of other techniques when it comes to data ingestion. Now you're working for some companies or clients, for example, and a client comes to you and says, hey, look, here are 1000 documents that I have. These are all confidential documents. You have to look at the footer and header, and you have to basically sanitize or redact. That's what it calls, sanitization, or redact those confidential information before passing it to model for whatever purpose. Then you have to add some other layer on top of this ingestion code. You can use a lot of other techniques. That's what I'm trying to say. But these are the minimal thing. What we are doing in this case, let me explain. We have imported all the required thing. Then we have defined directory, created a main function. We are loading the document, giving it to recursive character text splitter so it can split that, and then we are passing the document inside that text splitter. We are creating the embeddings, storing in that vector database, chroma.from underscore documents. That's what we are doing. For one document, 5 to 10 pages, it might take around 50 seconds to 1 minute on a CPU machine. 16 GB of RAM, and that's it, 16 GB of RAM. That's what you need, okay, for this one. I have even tried on 8 GB of RAM, it works. Trust me, even if you have 8 GB of RAM, it will work definitely. Okay, I have tried on my other system. Now let's run this, the ingestion piece of code. We'll first run this code because we are ready to run this. Okay, now here I come, and what I'm going to do here, I'm just going to run it. So how do we run this? We're going to just say Python, and then we're going to do ingest.py. Once I do this, you can see currently there is nothing inside this DB folder, but it will create a Parquet files, couple of files with index. That's what it's going to do here, and that's how it works, right? When you see keyword based search, right, indexing, it says we are indexing, right? That's the underlying concepts remain the same, guys. Okay, nothing changes. Now let's run this. Now you can see it has printed that fast facts what is climate change, because we have used this print file, and now we have this. If you click on DB, you can see that's what I'm trying to show you. Okay, when you click on DB, let me go inside this DB, guys. Now you have couple of Parquet files, embeddings. You can see 0100. Okay, it's embeddings, the lower dimensional space of your text representation. That's what embedding is. And then you have index. You can see metadata, and that's where we'll retrieve the source information, the citation. That's how it's going to help. When we have UUID, unique identifier, very intuitive, guys, right? It's data science, from data science to AI and machine learning. The journey is completely fascinating, and I hope you enjoying your time, with this technology that we are currently, working with. So if I come back, we are successful now with our ingest thing. Now what we're gonna do here, we have to basically use this embedding on top of a large language model for inference. Let's do that. Very simple. Come to this app.py. Let's import Streamlit first, because that's what we're gonna do here. So import Streamlit as st, something like this. Okay, import Streamlit as st, and now transformer thingy. So from transformers, import auto tokenizer. I'm gonna use auto tokenizer. Okay. You can also use T5 tokenizer, any other tokenizer as well. You have to look at that. Okay, you can play with it. Okay, auto tokenizer. I'm gonna use auto model for sequence to sequence language model. That's what I'm gonna use for modeling part to load the model. So auto model, and that for sequence to sequence, because it's sequence to sequence LM model. That's what I'm gonna use here. Sequence to sequence language model. Now the pipeline, tab9 is intelligent. I'm using tab9. Okay, you can also use Copilot. If you have $10 per month, you can use that. Now from transformers, import pipeline. Let's import torch. That's the backend. Import torch and import base 64. Did I say beautiful soup? Sorry, it was base 64. Okay, when I was talking about requirements txt, it was not beautiful soup. Okay, base 64. Import base 64. And what I'm going to do here is maybe you can also use text wrap, because when you get the output we have to wrap that. So maybe you can also import that. I'm not sure. Let's do that if we need it. Import text wrap, and now again the Langchain thingy. So from Langchain, so why I'm going to write here, I'm just going to use it from here, right? ingest.py. What we need here is we need these couple of things at least. So let's come to app.py. We need these two things, and we also need from Langchain. We need chains now. So chains, 4 different type of chains are available, I guess, in Langchain. I don't know if you have updated as well. They keep on updating, guys. From Langchain.chains, import retrieval. So I'm gonna use retrieval, and I think it's QA, retrieval QA. That's what I'm gonna use here, retrieval QA. Okay, chains. We also need pipeline that will pass the LLMs, right? So from Langchain dot hugging face, excuse me, from Langchain dot hugging face, not hugging face, I'm making a mistake, it's LLMs. From Langchain dot LLMs, then we will import hugging face pipeline. So hugging face pipeline, yes, that's it. So we have sentence transformer, embeddings, and chroma, and retrieval. We also need that chroma setting, by the way. So let's bring this guy here as well. So from constants import, I'm gonna use this chroma settings. That's it. That's our import for app.py. So beautiful, isn't it? Right now let's do that. So the first thing that we have to do, what we have to do is the checkpoint. So the first thing is checkpoint, and this checkpoint is nothing but this you see Lamini T5, the folder name. So let's use that. So that's called Lamini T5. You can see that. That makes sense. You can also remove that, it's not required, but you can also keep that. It doesn't go outside of the folder, it looks in that folder. This makes sense, this is correct. So I'm going to use tokenizer from auto tokenizer. This is also right. So model, auto model for sequence to sequence LM from pre-trained, but inside this I'm gonna use couple of things here. Let's define that, guys. Okay, so checkpoint, that's why we're using accelerate. So checkpoint, excuse me, I don't need all of you, sorry, checkpoint. And now I'm gonna use device map, device underscore map, okay, which is very important to understand, guys. What is device map? Okay, so device map has first three or four different type of values. Auto, automatically looks at your infrastructure, the environment. If you have a CUDA, if you have a CPU machine, and when you keep it auto, it automatically offload the weights. Okay, it automatically suffers those weights, whatever, you know, the number of CPUs if you have, even if you have one CPU in that case, right? That's what auto does, automatically looks at it. But if you want to explicitly defined that you don't want to keep auto, okay, you can maybe keep CPU, you can keep CUDA, because if I do here CUDA, for example, it will look at that if I have CUDA GPU or not. That's called, you are defining it in an explicit manner. Okay, that's what CUDA does here. Okay, and if you do CPU, it will look at only the CPU cores. Okay, what I'm going to do here, I'm going to just do auto. So let it define. That's why, you know, we're using accelerate here, guys. Very important, right, to understand this. Now we have defined device map auto, and now what I'm going to do here is I'm going to use the torch D type, the data type of the torch tensor. So torch underscore D type, and this is nothing but I'm going to use float32. So torch dot float underscore 32, or not underscore, dot torch dot float 32. That's what I'm going to use. That's what the model is doing here. So we have loaded our tokenizer and model. So in model we are passing that checkpoint, device map, and torch D type. That's what we are doing. Now let's write the function, guys. So define, the first function I'm going to write is LLM pipeline. Let's define our pipeline for text generation, because we are generating text. If you want to perform any other task like summarization that I have shown in my previous video of Lamini, please go through and look at that in LLM playlist, where I haven't used text generation, I have used the summarization pipeline. You can also do that, depends on what kind of task you are looking at it. So LLM pipeline, and in this LLM pipeline I'm just going to write all of my code. The first thing is pipe, and this pipe is nothing by the way, the pipeline. So I'm going to use pipeline, and in this pipeline I'm going to write all the things that are required. So the first thing is text to text generation, because we'll have our input text, which is a query, the question that we'll ask, and it will respond some text in, text out. Text to text generation, that's the first thing. Now the next thing is model equals model. So I'm just going to write model equals model. So let's write that. Okay, maybe let's define that as base model. So model equals base model, underscore model, by the way, base underscore model, and model underscore tokenizer equals tokenizer. So this is okay. And now what I'm going to do here, I'm going to define a maximum length of tokens as an output. This is for demo purpose, this is for you, so you can understand, learn from this model, this video basically in general. You can play with these numbers. Totally depends on what kind of machine you are using, the infrastructure. In my case, I'm just going to do max token here, and max length, sorry, not token, it's max length. And max length I will keep 256. You can keep 512, 1096 as well, depending on what kind of machine you are using. So max length 256, and I'm going to do sampling equals to 2. So do sample, by the way, sorry, do sample equals true. It's a boolean value, do sample is true. And I'm also going to use some top P, for example, creativeness and temperature. So let's use temperature for randomness and creativeness. So how creative the responses are, right? So temperature and temperature equal to 0. Let's keep a very small temperature number here. Okay, I don't want to be too creative. Okay, temperature, otherwise we will not get good responses. Temperature, because it's a QA tool, you like to have an exact response, maybe very similar. But if you are building a chatbot, you might want to increase this temperature value. So now we have temperature. Now let's use top P, top underscore P, 0.95, the standard 0.95. This makes sense. Now we have done this. What are we doing here, guys? Creating a pipeline for language model and text to text generation task. Model has been defined, tokenizer has been defined, some parameters has been defined, very fundamental. Now the next thing that is we have to use Hugging Face pipeline here. So local LLM, I'm just gonna use Hugging Face pipeline, not manager by the way, Hugging Face pipeline. And here I'm gonna pass pipeline equals pipe. Here we go, local LLM. Let's return this local LLM, guys. Now this function LLM pipeline kind of contains our local language model, Lamini. Here I'm going to use a decorator because in the runtime I don't want to load this model again and again. So I'm going to use cache resource by Streamlit. You also have cache data if you want to, if you're working with CSVs and numpys and etc. So ht.cache resources, I'm just going to call cache resource. It's not resources, I guess, it's cache resource. Here we go, the first function has been defined and looks good. What we have done so far, all the libraries have been imported. Then we have this models, tokenizer, and parameters, device map, then LLM pipeline function, text to text generation, tokenizer, maximum length. You can tweak these numbers. Now here we go, the question answering LLM. We have to use all of the things, embeddings and language model, right? So let's write that function, QA LLM. And in this, the first thing that I'm going to do here is I'm going to call this LLM pipeline function. So LLM pipeline, the function that we have defined on top, LLM pipeline. The next thing is embeddings for sure. So embeddings, and for embeddings we need sentence transformer, and the model name again will be the same. So let me do one thing, let me just bring that from here, model name, and I'm just going to use that here, model name. Embeddings has been done. Now DB, and this time not from Chroma dot from documents, it should only be Chroma because we are just loading that embeddings. Let's do that. So Chroma, and in this Chroma persist directory, the first thing, so persist directory, and the persist directory is nothing but the DB. Let's define it right here. So persist directory is DB, and the next thing that I'm going to do is embedding function, and inside this embedding function let's write this embeddings, by the way, embeddings, and then the client setting again, DuckDB Parquet. Okay, so client settings, this is not going to be client setting like this, client settings, it will be Chroma settings. Here we go, Chroma settings. Let me do an Alt G, Chroma settings. Now you can see Tabman is very smart. Okay, so it's very intelligent. I will say smart is not the right word, very intelligent. Now DB we have defined, okay, this is the folder, get the embeddings from here. Now we have to retrieve that, and that's where Langchain retrieval chain comes in play. So let's do that. So retrieval, okay, so let's write retriever, and in this retriever I'm gonna use db.asRetriever. Here we go, db.asRetriever, and in this retriever I'm gonna pass couple of things, not in this retriever, the next, the chain. So retriever db.asRetriever. Now this contains that embedding that we need to inference this particular retriever, and here we go, the QA. Let's define the QA. So QA, the question answering. In this I'm gonna use retrieval, retrieval QA. I'm gonna use this, and inside this I'm gonna use couple of things here. So retrieval QA, the first thing is, it's not retrieval QA, okay, it's retrieval QA dot from underscore chain type, I guess so, from chain type, it seems like that. Let's see if we get any error, guys. So retrieval QA dot from chain type, okay. And now what I'm going to do here is, the first thing is LLM, so LLM equals LLM, and the next thing is chain type. Let's keep it stuff. Now chain type is also very crucial. For summarization task you use MapReduce, right? It depends what kind of chain type you are using, it totally depends on the task that you have. MapReduce is there, okay, and then I think there are 4, okay, I completely forgot the other 2, MapReduce, stuff, and a couple of compacts, a couple of others as well. So chain type, so the chain type equals to stuff, and the next thing is, chain type stuff, and the next type here it goes, the retriever equals retriever, this will be retriever equals, and then return source document. We need that for metadata. Okay, so return source documents. So return source document, and in this return source document, what I'm going to use here is true. It's a boolean value. Either you give a false or true. Here we go. Our function has been defined, guys. Now let's return this QA. Let's use st.cache resource in this case as well. We have to cache the resource if we are in the same runtime, okay, on Streamlit interface. What we have done, we have written two functions, very intuitive functions. Okay, these are the crucial functions. Most of the POCs that you are building, most of the projects that you are doing with large language model on documents, this will be the workflow. Okay, now what I'm going to do here, I'm going to write one more function for process answer. So let's do that. So what I'm going to do here is define process answer. So process underscore answer, and inside this I'm going to pass my instruction, the question that I have. Okay, so let's call it instruction process answer instruction, and here I'm going to use a empty string for response. So let's do that. This goes like this, response. I'm going to use instruction, and instruction I'm going to use instruction. So this is going to be my instruction, by the way. That's it. And here now let's call that function, the function that we have defined on top, QA LLM, and in this we'll pass our instruction. So QA LLM, now let's have a variable called generated text that will hold our generated text. So let's call this generated text, pass that instruction inside this QA. That's what we're going to do here, generated text QA instruction, and we'll have our answer. So answer, so we only need a result, answer, and metadata. So let's do that. So answer, I'm going to use generated text and only the result. So result, generated text result. Okay, so let's do that. So this is what we are doing here in this guy. So we have generated text, QA instruction, generated text result. This looks nice. What else? Now answer is done, so let's return this, by the way, so far. So return answer and also generated text. Okay, let's return both answer and generate. Let's see that, okay, what kind of responses we are getting. So response instruction equal to instruction, QA LM, generated text, QA instruction, answer, generated text result. This looks nice. Return answer generated. Now here we go, we have to write the Streamlit function, guys. So let's write a Streamlit thingy. Okay, so let's define a main function, and inside this the first thing is st.title. In st.title I'm going to write here search your PDF, something like this, search your PDF, and I need a couple of emojis. So let's search for parrot emoji, which is for Langchain. So parrot emoji, where can we get this parrot emoji? Allow all. Can we get this guy? So let's use this guy. So this is what we have doing. I need a red one. That's how it resonates to Langchain, but this is okay. And then I need a PDF emoji, PDF page facing up emoji. This looks okay. Let's use this, and I'm gonna use this. So we have emojis also to make it little fancy, you know. And then let's call with st.expander, with st that kind of looks at some label about the app, and here we go. Inside this I'm gonna write some markdown and stuff here, okay, maybe. So st.markdown, so st.markdown, and inside this I'm gonna write couple of things. So inside this, and let me just, this is a demo. This looks nice. This is a demo of search engine for PDFs. No, not like this, not a demo, guys. This is a generative AI. This is generative AI powered question and answering app that responds to question about your PDF file. That's what I'm gonna write here, about the PDF file. So let's do that. PDF file. This is what I want to do here. Now this is done. Let's get out of this, okay, and let's have a variable called question here, and this question will nothing but the text area. So let's call this st.text area, and inside this I'm gonna use here enter your questions. So enter, by the way, sorry, enter your question, and enter your question. Excuse me, why I'm giving this code, I don't know. Now text. Now let's have a button called if st.button. This button should not be, let's give it something like search or something, okay. st.button search, and here we go. We're gonna use an info here. So st.info, and I'm gonna use your question, and your question, for example, something like this, your question plus this go question. This is okay. So your question and question, and I'm gonna also use st.info, and inside this your answer. So let's do that. So your answer, this is okay. It says connection failed because there's a power cut in my area. Your answer, we don't need power anymore because we have downloaded the models. st.info, your answer, and here we go, the power came back. Let me just do this by monitor. Your question and your answer, by the way. Yes, so here we go. Let's couple of variable, answer and metadata. So we store this answer and metadata. I'm gonna use that function called process answer. I'm gonna pass this question. So let's pass this question, and that's it. st.write, maybe, for example, let's write st.write, and this should contain my answer, and then st.write with the metadata. So this should contain my metadata. This is the app that we have built, guys. Okay, so we have written the code now. Okay, let me just also do if main, excuse me, I don't know, that's, I have to handle that from JSON file for VS Code. Let's do this if name. So if underscore name and underscore equals, and I'm gonna use here underscore main underscore, and that's where, you know, when you need tab 9 help, it doesn't help you. Okay, main for this manual. Okay, this makes sense. Okay, so we have main, it's okay. So what we have done in this app.py, imported all the libraries, loaded the model, written the LLM pipeline function, QA LLM, where we are using all those things that we have done. This function kind of utilizes everything that we have done so far in ingest and wherever model. This basically process the answer, and this is the app. Let's run this, guys. Why are we waiting for? So what I'm going to do here, I'm going to run this. So let's run it and see if we get any error. So if you come over here, let's run Streamlit, run app.py. Meanwhile, let me minimize this. You can see we have got our app. It shows search your PDF. I can see some spelling mistakes, but this is okay. About the app, when I push it on a GitHub repository, it will be even more fancier, at least. Okay, about the app. This is a generative AI powered question and answering app that responds to questions about your PDF file. Let's ask the question and see if it's able to retrieve. That's why we have built this. So let me ask, what is climate change? This is the question I'm asking. Let's ask this and see if we are getting any error or if it's able to give me the result. Now, once you ask this question, it might take up to few seconds to few minutes as well, up to few minutes, because it has to run that on, it's running on a CPU. Here we go. It didn't even take 30 seconds. Okay, it was like too fast. Climate change is a natural process where temperature, rainfall, wind and other elements vary over decades or more. Fantastic. Here is your query, because we have the metadata, and again you can customize it. Okay, customize it the way you want. That's the power of large language model. Okay, you have to appreciate large language model, guys. Okay, if you see query here, what is climate change? Now the result is climate change, the same result that we have printed over here on top. Now we're also giving you the source document, and you can see the source document is our PDF. It's not the Lamani's knowledge base. It means the model is completely working fine, okay, to retrieve the information. And you can see also it's giving you the paragraph. climate change, blah blah blah, metadata, you can see source, and we have around 0 to 4. You can again control it, the number of k in the source document. You can pass k equals to 1, for example, if you only need one source, but it's okay, you can play with it. Please watch my previous videos as well, where I have shown all these techniques on the how to only retrieve one source, or how to use custom prompts, etc. Now if you see in this source document, it's retrieving the information from that. It's not hallucinating, it's given you the right answer. What is climate change? So climate change is a natural process where temperature, rainfall, wind and other elements vary over decades or more. This is amazing, isn't it, guys? Now there can be two things. If you are on a very limited, if you have a very limited memory, okay, and computational power in your machine, when you ask the second question, it might crashes your application. So again, you have to start. You have to end the runtime, end the task from task manager or somewhere. You have to restart again because it's compute heavy. So you have to rely on something else, like some other virtual machines and some GPU based machines. Let me do one thing. Let me show what the error I'm getting. Okay, when I run it again. But that's completely fine. Okay, because you don't expect this to deploy in production on this kind of CPU machine. At least not on one CPU. At least you need minimum of 8 CPUs with many cores. So what else we can ask this, guys? Let me read it. Highest level in 2 million years. As a result, the Earth is about 1.1 degrees Celsius warmer than it was in 1800. Let me ask a question. Okay. People are experiencing climate change. Let me ask this question. Are people experiencing climate change? Let me see this. Okay, the question that I have asked. Let me ask this question and see if I get any error. So I'm asking this question, but it will probably crash. But this is completely fine. Okay, okay, see, yes, we got the answer. Yes, people are experiencing climate change in diverse ways, and we have maximum number of tokens as 256. That's why they're getting this concise answer. If you increase that, it will get a bigger answer as well. Yes, people are experiencing climate change in diverse ways. You can see that, right? And again, the same document, fast fact, what is climate change, the same PDF that we have uploaded. This is fantastic, right? You can see, right? And this is what I wanted to do in this video, guys. I hope you understood, okay, and how simple it is to build this kind of application. But there are too many of challenges when you do this for a client. For your client, if you're working in IT industry or at your workplace, you have to look at many other factors, because before deploying it to production, how to control hallucination, what are the response validation mechanism you put in place, how you validate the response, you put this source document citation so it can at least give it little explainability on the output, and this model should not be too opaque, right? So there are a lot of challenges when it comes to work with these models, the language models, but they are improving. I will recommend this model, because this works fine for summarization, for retrieving question answer. In the next video I will create a chatbot kind of a interface, okay, with the same model. So this code will be available on GitHub repository, the entire code that you see here, okay, entire code will be available on my GitHub repository, okay. And if you have any question, thoughts, feedbacks for me, please let me know in the comment box, okay. And if you want to reach out to me, you can reach out to me through social channels, and I also have created a community on WhatsApp. If you want to join that, please find that in our YouTube banner, okay, the link is there, can also be given in the description as well. So I hope you learned something from this video, guys, how to create chat with PDF, chat with your data, search your data, whatever you name it, application, okay, with completely open source models, no OpenAI, no closed source models or services, okay, it's completely open source. We haven't used internet also. You saw that power cut, right? Without internet we were writing our code and running the models. So that's all I wanted to do in this video. It was very very intense, I will say, this video, because I think it's a long video, but from theory, the workflow, the code, I wanted to cover everything. And please like the video, Okay, if you like the content and if you haven't subscribed the channel yet, please consider subscribing it. That will motivate me to create more videos in future. Okay, that's all for today's video, guys. Thank you so much for watching. See you in the next one.